be talking about 10 top areas to practice rigor and mitigate anti-patterns. And our book, as Chester was mentioning, is How to Lead in Data Science. And it's a practical guide for the unique challenges of data science leadership at all levels. So we're going to be first talking about.
Yeah, next.
So we're going to be talking a little bit about trust. And it's something that for you to succeed as a data professional, you need the trust from across your team, across your leadership, and trust is precious to build for all data science work. And much of the trust in data and modeling comes from the rigor with which data professionals treat the subject. So what are the different components of trust throughout the data professional's career? So at the very top level, you think about it, you have the component of trust. You have the first thing that comes to mind, which is the ability to produce an accomplishment. And what's required are the data analysis and modeling techniques involved in technology and expert knowledge. So by technology, we mean the tools and frameworks for you to lead projects more effectively, which are used in framing the problem, understanding data characteristics, innovating in feature engineering, driving clarity in modeling strategies, and setting expectations for success. By expert knowledge, we mean the domain knowledge for you to clarify project alignment to organizational vision and mission, account for data source nuances, and navigate structural challenges in an organization. So data science is still called data science for a reason. There are many pitfalls in which we conduct data science, and the ability to produce accomplishments despite challenges and disruption can be crucial for success. So that's the second level of trust. And what's required are the abilities to execute on projects and be rigorous in the process. By execution, we mean the practices for you to specify projects from vague requirements and prioritize and plan projects while balancing difficult trade-offs. By rigor, we mean the craftsmanship that generates trust in the results data scientists produce. Rigorous results are repeatable, testable, and discoverable. Rigorous work products can become solid foundations for creating enterprise value. Data science also involves interacting with sensitive data across many functions. So the virtue of building long-term relationships, the next level, the ability to build long-term relationships while accomplishing your goal is extremely important. And what's required are strong ethical principles and positive attitude. By ethics, we mean standards of conduct at work that enable data scientists to avoid unnecessary and self-inflicted breakdowns. And by attitude, we mean the moods with which a data scientist approaches workplace situations. Together, these three areas are summarized as competence, reliability, and sincerity. Think about it as three-legged stool. With anyone missing or weak, you're going to compromise on trust. Next. So today we're going to talk about rigor. So you saw there's 6 areas: technology, domain expertise, execution, rigor, ethics, and attitude. Today we're going to focus on rigor. And there's different rigor required for increasing responsibilities. The 4 levels of rigor are team level influence, multi-team level influence, function level influence, and company level influence. And we have the persona on the right to correspond to each one of these. So Jennifer is going to be focused on, Jennifer is at the team level influence, whereas Audra, a manager, is at the multi-team level influence, and Stephen is at the functional level influence as a director, and Katherine as an executive is at company level influence. So let me introduce the authors a little bit and speakers. We happen to be classmates. and we became partners in life and partners, co-authors on this book as well. So first, Dr. Jike Chong has personally mentored and promoted many data science leaders in the US and China in public and private companies. As an executive, he's built and grown multiple high-performing data teams. Dr. Chong is an executive at Antidote Health, a telehealth company looking to bring quality healthcare to the uninsured and underinsured. He was part of the executive team that took Eden Digital Limited public on New York Stock Exchange. He also expanded and led the data team as a chief data scientist at Acorns. He designed and executed a project predicting venture investment risks at Silver Lake and led the hiring marketplace data science team at LinkedIn. And my name is Cathy. I go by Cathy. My full name is Cathy Chang, and I'm and I've built and led teams at Silicon Valley Data Science, where my team and I parachuted into companies to address challenging and meaningful data needs. You notice the logo, the number of logos. The first level logos are service companies, second level are startups, and the third level are large companies. And I also want to highlight WSWA, that's Wall Street Women's Alliance. It's an inter-firm network dedicated to creating culture that enables women to advance to senior leadership roles. So you notice at the bottom of the page, there are a couple of QR codes. If you are interested in learning more about how to lead in data science, there's a publisher's page and there's Amazon page. Now a little bit about the book. We have, there's our contact information and a few editorial quotes by some of the senior data professionals in the field. So today, very important for you guys, there's an opportunity to win a free book. And we have a LinkedIn page that's for how to lead in data science, and the QR code at the bottom right is where you can scan and follow us. So how we're going to do the book giveaway is we're going to look at the new followers. So if you have already followed us, just send us a direct message when we include you in the drawing. So we're looking forward to you. This is where we're going to be sending insights, examples, experiences, and other things that we cover from the book, and things from the market as well.
Yeah, that's a forum that we frequently give updates. And so far, we've been taking some snippets from the book, like the gems, some interesting quotes from the book, and sharing them online. And hopefully they will be useful and be able to trigger some useful thoughts in your leadership journey. So with that, let's get started with these different levels of rigor. So Cathy earlier mentioned that there are 4 levels of rigors, and we'll start taking you through these levels of rigor through actual personas, inspired by people who we have worked with and who we have worked for.
So let's first take a look at Jennifer, the tech lead. She's got a background in chemistry and statistics. She joined the current company about 6 years ago and promoted to, she got promoted twice in the last 2 years. And she started in business intelligence BI, and she's a founding member of her company's data science team. So recently she got promoted to a tech lead. As a senior data scientist, when she was in that role, she's passionate about making data available for analytics and modeling. She's efficient in implementing functional data pipelines and effective in training and tuning machine learning models. She's super excited to take on new responsibilities as a tech lead. So let's take a look at these characteristics that she has and see if they are enough for her as a tech lead.
Yeah. So let's get started. The 10 areas and the 10 mistakes. The top one, Cathy mentioned that Jennifer is passionate about making data available for analytics and modeling. Now, one of the mistakes even made by people with the best intention is that they may neglect the correctness and completeness aspect of making data available. And the consequence is that the data may appear in the wrong format, or there may be incomplete information that causes wrong conclusion to be drawn. So to be rigorous in tracking and getting new data sources into our platforms, it's not enough just to track the events and have the data available. The correctness and completeness also need to be tested. And correctness may fail if data just appears in the wrong format. For example, we often have timestamps in our logs. And if the time zone label is missing, often analysis may fail. For completeness, it may fail if not all signals are captured reliably. And this may happen simply because the inherent best effort delivery mechanism of the internet, causing some browsers to suppress certain type of requests. So as solutions, you can build or buy data observability capabilities. In my work at Irin Digital, we actually built data observability capabilities as a first-class citizen in our data pipelines. And these include checks on data freshness, distribution, data volume, and the correctness of the schema, as well as data lineages. And that was 6 years ago. And nowadays, there is a new emerging breed of data observability platforms that can help you improve data reliability. So for example, there is a company called Monte Carlo that has gotten quite a bit of traction, and they target data users and helping them make visible the data freshness, distribution, volume, schema, and lineage information so that they can judge for themselves whether there are issues in the data pipeline or not. There's also a company called Metaphor Data that is a startup founded by members coming from the from LinkedIn team that targets data producers, which in an organization with some good data maturity and data literacy could actually mean a wide range of roles in the organization. So with either of these kind of solutions, you may already have some off-the-shelf solutions that can help you resolve data observability capabilities.
So this is the area number 10, focusing on data availability. But from Jennifer's perspective, she may have neglected data correctness and completeness, and there's some consequences to it. And the solution can be built, and can be bought.
Yes.
Next. Just a quick check. Is everybody seeing the screen okay?
Yeah.
Yes.
All right. Good. All right. So for number 9, Jennifer, as Cathy mentioned, Jennifer is efficient in implementing functional data pipelines, but she may be neglecting the cross-checks and cross-validations to have a more defensive checks on the pipeline robustness. And this can have many consequences. Well, the data pipelines may be functional, but they can be fragile. And what people see is that there's frequent data incidents. And when you're looking to resolve them, the issues are hidden and hard to debug. So to be rigorous is not enough to implement the data pipelines. Defensive coding techniques such as assertions, cross-checks, cross-validations can also help you increase rigor at the code level when performing analysis or building models. So by assertion, we mean the Boolean expressions at a specific point in a program or in a data pipeline, which will always be true unless there is a bug in the program. And the execution of the program can stop at an assertion when it's not satisfied. This way, when there is correctness issues, it can be detected as soon as it happens before they propagate to a later part of the data pipeline. By cross-checks, we mean the use of redundancy principles to overcome a result from different analysis angles. And the common angles include the top-down and the bottom-up analysis. For a top-down analysis, that's where you make an estimate based on what is the part from the whole. And for the bottom-up analysis, that's when you have an analysis produced as a summation of the contributing parts. And these kind of cross-checks can quickly uncover issues when you have missing data or uncategorized data that can fall out of an analysis scope. What you can also do is cross-validation. And cross-validation is maintaining the same methodology and selecting multiple random samples of available data to see if the methodology are robust enough to arrive at the same conclusion. Cross-validation can quickly detect if an interesting result was an artifact of some unusual sampling of your data.
So this is area number 9, focusing on building functional data pipelines. But Jennifer here may be neglecting defensive pipeline robustness checks. There are some consequences to that. And the solution would be using defensive coding techniques such as assertion, cross-checks, and cross-validation to improve robustness.
All right, we're down to number 8.
Well, we need to speed up.
Yes. So in this particular case, Jennifer is effective in training and tuning machine learning models, but she may be neglecting the data drifts and concept drifts that may emerge in operating these models. And the consequence is that the models may perform very well at first, but the performance would degrade over time. And what this means is that the projects will fail to achieve the expected business return on the efforts invested. Now, rigor at this particular level is vital for data science. And especially this is after an analysis or model is deployed and the attention has been switched to other projects. So the two scenarios we talk about is data drift and concept drift. Data drift is when the model was trained on a certain distribution of inputs, but this distribution changes over time. For example, for a credit card approval algorithm, it can be trained on data from one advertising channel, but it can be applied to applicants from a new advertising channel with a different mix of customer backgrounds. Or it can be applied to a life insurance model, for example, predicting life expectancy, and it can be trained on a data set with very few smokers, but then deployed in an environment with more smokers in practice. Then there is a concept drift. Concept drift is when the meaning of the features change. For example, the model was trained in one mapping, going from features to outcome, but then the statistical relationship between the features and outcome changes. So the same features now demand a different prediction of the outcome. So for example, in the credit card case, when the economy goes through boom and bust cycles, borrowers' ability to repay can move up and down with their job security. And for the life insurance case, what was breakthrough in medical advances, life expectancy for certain pre-existing conditions may change, and people may live longer, so that some medical conditions are no longer as fatal. So how do you detect these changes? Well, you can monitor the accuracy of models by measuring the difference between predicted and observed. But in the credit card case and the life insurance case, you may need to wait for months, years, or even decades before you can see whether the observation will match the prediction. So as an alternative approach, you can detect anomalies in the input and output of your model. So anomalies in the output can manifest as excessive numbers of positives or negatives in the predictions. And by looking at by looking at shifts in the input distribution, you can look at the variety of distribution divergence estimates. And one of the example is the population stability index, which is a form of Kullback-Leibler divergence. And PSI, population stability index, measures how much a variable has changed in the distribution over 2 points in time. And these 2 points in time can be over consecutive days, which can detect sudden changes, or it can be between the time of model launch and the current time, which can detect slow drifts over time that may not show up across multiple consecutive days.
Yeah. So this is area number 8, focusing on performance at training time. But Jennifer here may be neglecting data drifts and concept drifts. Again, consequences and solution. So for solution, we can monitor input and output stability with distribution divergence estimates, such as population stability index.
Yes.
So that brings us to a quick summary on Jennifer. Jennifer, as a tech lead, she was recently promoted to a tech lead. While a senior data scientist, she's passionate about making data available for analytics and modeling. She's efficient in implementing functional data pipelines, and she's effective in training and tuning machine learning models. But what she can, as a tech lead, she, in addition to focusing on data availability, she also needs to focus on data correctness and completeness. And in addition to focusing on building functional data pipelines, she also needs to look at defensive pipeline robustness checks. And in addition to focusing on model performance at training time, she also needs to pay attention to data drifts and concept drifts to be successful in her new role. Now, next is Audra. Audra is a career-focused manager. She has a master in computer science, and she's been an individual contributor for 3 years. And now she's managed 4 data scientists for almost 2 years at a startup. This is a different situation. It's not a promotion situation. She's actually interviewing outside for a manager position in a larger company. And she's diligent in building machine learning algorithms while anticipating data and concept drifts. She's effective in building a data-driven culture by democratizing data access. And she's focused on a rapid experimentation to drive insights with velocity. Now, as a manager, is this level of rigor sufficient?
Yes. So Cathy mentioned that Audra is diligent in building machine learning algorithms while anticipating data and concept drift. So now we see that she's already more mature than where Jennifer was. But just focusing on the machine learning code and neglecting the data and deployment infrastructure could also be dangerous. And the consequence is that the glue code that's around the machine learning code can be pretty costly to maintain. And the performance of your machine learning algorithm can degrade when the use case has to be tweaked to match the algorithm's implementation requirements. Now, for machine learning algorithms, they can be computationally intensive and complex to tune. But fortunately, there are pre-optimized machine learning library components that we can use today, off the shelf. And many of them are even available as downloadable open source components. But the challenge is that each of these components has been designed for specific usage scenarios that may require input and output of specific formats and accessible in specific language. Now, to take advantage of these library components, there's a significant amount of glue code that is often implemented to connect your specific use case to these existing library components. And the Scali's paper at NIPS in 2015 has illustrated this well. And you can see from the figure that the machine learning code is often just a small component of all the infrastructure that's deployed at companies. So in order to maintain this large amount of glue code, it can be really costly over the lifetime of a system. But there are ways to be able to get around it. So to mitigate this glue code issue, you can wrap certain specific algorithms certain specific algorithm implementations with an API that can work in multiple alternative algorithm implementations. And for example, a good illustration of this is in Python, machine learning ecosystem. Scikit-learn has done this really well, right? It can allow hundreds of algorithm implementations to share a relatively small subset of input and output connectors. And in large companies, sometimes you have customly built algorithms specific to one's use case. But it's often good to be able to wrap these kind of implementations with commonly available APIs, so that as you evolve your machine learning ecosystem, these in-house implementations can be upgraded to open source solutions later on, or open source initial solutions can be upgraded to some specific in-house implementation later on.
So this is area number 7, focusing on the machine learning code. So Audra, in this case, may be neglecting data and deployment infrastructures. There are some consequences to that, and the solution she may choose to implement would be wrapping specific machine learning algorithms with API that can work with multiple machine learning algorithms.
Well, Cathy also mentioned that Audra is effective in building a data-driven culture by democratizing data access. While it's great in focusing on democratizing data access, she also needs to look at data lineage and maintenance. And the consequence of missing out on data lineage and maintenance is that the data processing pipelines may quickly become unmanageably complex, and the data outages can be frequent, and the executive pipelines, the data pipelines, and the production models may not be able to meet their service level agreements. Now, to democratize access to data, what we're all often doing are opening access to the centralized data repositories and sharing them with multiple teams. And initially, this can maximize collaboration and reuse in an environment with always constrained resources. But as the number of contributors increase, the lineage of the producer-consumer relationship can also get complex very fast. And it's not uncommon to have data propagation pipelines that are 4 to 5 levels deep. And sometimes you can have a data dashboard with a union table that may aggregate information from hundreds of raw data sources and tens of data preparation with tens of data preparation steps. And when a particular set of summary data is selected to be an executive-facing operational metrics, it can quickly cause issues when the reliability becomes a challenge. Now, this logical dependency is further complicated by the scheduling steps in these processing pipelines. And when you change the surface level agreement for some of these pipelines, it can have cascading effects on your data pipeline efficiencies. So in this particular case, the collaboration between people, the collaboration between data scientists and data engineers are crucial. So specifically, you want to be documenting the data lineage, checking the reliability of particular tables before creating any dependencies in your data pipelines. You should also be acquiring data from the earliest point in the data processing pipeline as possible, so to trim down the fan outs for your data pipelines. And what you should also look into is allocating the time for refactoring your data processing steps as a way to cut down on the tech debts in your data pipelines.
So area number 6, focusing on democratizing data access, where Audra is doing a great job. What she may be neglecting is data lineage and maintenance. There are consequences to that. And the solution is to nurture team to consider trade-offs in reliability and model performance. Next.
So also another area Cathy mentioned is Audra's focused on rapid experimentation to drive insights with velocity. And this is some desirable property that many organizations are looking to mature into. But the challenge with rapid experimentation is the neglecting to clean up the dead code path afterwards. So the controlled experimental methodology often use conditional branches in the code flow within the production code to send a limited portion of users down alternative code path to test new features with reduced risks. But while some of these experiments lead to positive results, many of these paths leads to potentially negative results, and they may be discarded, tested once and abandoned, yes. So while the cost of each individual change may be low, when an organization performs hundreds to thousands of experiments a year, the accumulated abundant code path can become overwhelming.
Abandoned.
Thank you. Abandoned. Yes.
Throwaway versus plenty.
That's right. Especially like when there's some churn in the data engineering teams or the engineering teams, there can be a number of these conditional branches and flags for alternative code paths. And it can be hard to understand, maintain, and they may become actually a significant liability. In 2012, some people may remember that Knight Capital trading system lost $440 million in 30 minutes. And the root cause there was diagnosed as unexpected behavior from some obsolete experimental code path that remained in the code base for almost 10 years and somehow reactivated by a reuse flag. And that's the consequence that we talk about, that for some product managers, they see that the code is so intertwined that they joke that you can flip a switch on the 4th floor of building 10 and the toilet flushes in building 14. So the solution is to really periodically declare experiments to be deprecated and work with the engineering team to rip out and clean up the dead code branches as a data science manager.
So area number 5, focusing on rapid experimentation, where Audra is doing a good job, but she may be neglecting cleaning up dead code path afterwards. So for her to mature to the next level, she can implement solutions such as periodically declare experiments to be deprecated and work with the engineering team to rip out and clean up dead code branches. So let's take a look at Audra from a summary perspective. She's a career-focused data science manager, diligent in building machine learning algorithms while anticipating data and concept drifts, effective in building a data-driven culture by democratizing data access, and is focused on rapid experimentation to drive insights and with velocity. While she's focusing on the machine learning code, she also needs to focus on data and deployment infrastructure. While she's focused on democratizing data access, she also want to look at data lineage and maintenance. And for rapid experimentation, focus on cleaning up dead code paths afterwards as well. And as you can see, consequences could be dire if not done otherwise. So next, let's look at Stephen, a respected data science director. Stephen has been an analytic and data science leader for over 15 years in the transportation industry. A few years ago, he had the initiative to take some courses from an online education platform in machine learning and founded the data science practice in his last company. He joined his current company 6 years ago, well respected for his statistics background, has excellent working relationship with partners, long tenure at the company, everything's just checking. He was recently promoted to a director of data science to manage 3 data science teams, each with a dedicated internal customer, supply chain, financial planning, and marketing. It's a big role. So something is bothering him. There's not everything's checking. But he's good at many things. He's diligent in the details of planning. He can rally the team to deliver projects on time. He's efficient to complete projects and agilely committing the team on new endeavors. So what might be happening, and why is it there's some team morale issues, and what might be happening?
Yeah, Cathy mentioned Stephen is diligent in the details of planning. So what's happening in this particular case is that he's neglecting the purpose of planning and trackability. And this has consequences like death by planning. A plan is developed and reviewed, but is not tracked against execution. Or there can be overly complicated plan with untrackable amount of details. So here we're talking about this notion of anti-pattern. An anti-pattern are undesirable data science practices that increases the risk of failure. And it's like a chess master who can observe a chessboard and articulate which side is winning or losing. A data science leader should be able to observe and detect these anti-patterns in their project before the project begins to fail. So for Stephen, in this case, the plan can be developed and reviewed at the beginning of the project. But if it is not updated or tracked against execution, then there can be many emerging issues that are not promptly communicated with stakeholders. So the stakeholders can be surprised when deadlines arrive and the project's not complete. And this often happens in organizations when the focus is on controlling the schedule rather than delivering the result. In the case when a plan is overly complicated, it may show an untrackable amount of details, and there is a perception that everything is under control. Well, too much time is just spent on planning rather than delivering the result. So when delay happens, then too much time is again spent on updating the plan, which causes further delay and further replanning. So the cause for these failure modes come from a lack of a pragmatic, common sense approach for planning, scheduling, and tracking. And a project plan actually only needs to be as detailed as the milestones you can track. So for example, milestones at the sprint level granularity for 5 to 10 days at a time are probably detailed enough for many purposes. And when you're tracking these milestones, you can have clear definitions of particular state, such as on track, delivered, early, at risk, or late. So the goal of tracking is really to learn about deviation from expectation, such that future estimates can be more accurate. And effective tracking can build trust between you and your team leads as a data science director, and pave the path for data science functions to better work together with other functions to deliver projects successfully.
So this is area number 4, focusing on details and planning. Stephen may be doing that well, but he may be neglecting the purpose of planning and trackability. So in the interest of time, I want to ask you to go through 4, 3, and 2, and then summarize them together.
All right. So for number 3, Cathy mentioned that Stephen can rally the team to deliver projects on time. But sometimes it can be a fire drill kind of situation. And in those situations, he may have been neglecting delivery quality and piling on tech debt in the process. So the fire drill pattern occurs when the project is initiated but delayed because of design, data, pipeline, or scheduling or team politics. And often at the risk of being canceled, the team makes a desperate attempt in completing the project in a fraction of the time, compromising on the scope, quality, and creating mountains of tech debt in the process. The tricky thing is that some leaders may actually be incentivized towards this pattern. So in the normal course of a project, you can have specifications and architectures go through rigorous reviews and iterations before being declared acceptable to go on to execute. In a fire drill scenario, though, the management team may be accepting any specifications and architecture that can complete the project before the deadline. And this urgency may actually make the job easier for tech leads to get through the specification and architecture review process at the risk of creating tech debts that has to be paid soon in the future. And rigorous data science cannot be performed in this kind of fire drill scenario. And here, a few potential root causes for the fire drill scenario can include analysis paralysis, like when the team is stuck in a protracted period of data analysis and planning. It can be stuck in schematic engineering when the project is stuck in architecting the schematic phase and can't pass the review process. Or it can get into these situations with volatile specifications where stakeholders cannot agree on some particular output details. As a director, what you can do is guide the team to recognize these at-risk or late state of the project and find ways to get back on track. And you can also architect APIs such that the internal components to data science can be implemented first, and they can go through these APIs to flexibly adapt to the variations of output formats by the time that your partners have them defined.
Let's go to area 2.
Area 2 is when Cathy mentioned that Stephen is efficient at completing projects and can agilely commit the team on new endeavors. This is often plus, but often this also has this anti-pattern called throw it over the wall, which bypasses an effective handoff. So for this particular throw it over the wall pattern, they can occur when projects are developed by one team and are intended to be operated by another team. So for data science project, this can happen when a model is developed by the data science team and is going to be maintained in production by the product engineering team or site reliability engineering team. Now, this can happen when the model may be code complete, but not yet rigorously tested, or is weakly documented and under tested. And that can make the models susceptible to unexpected behavior in operations. And this can result in the user experience being degraded very quickly. So the solution is to allow time for testing, documentation, and anomaly monitoring, and to set clear expectations during the scope to cut, during scope cut to limit the tech debt with payback plans.
So Stephen, well-respected director, he is diligent in details of planning, can rally the team to deliver project on time, and is efficient at completing projects and agilely committing the team on new endeavors. The 3 areas that he can do even more is, in addition to focusing on details of planning, he can focus on the purpose of planning and trackability. He can also focus more on deliver quality and piling it on the tech debts. Don't let that take over the main focus. And also he can do more in terms of effective handoffs and not get into the throw it over the wall syndrome.
Yes.
So,
and all these can help improve the team morale for him.
Absolutely. So Katherine, a data science executive, she's a PhD in computer science with 10 years of industry experience, 6 years as head of data science at public and private companies, joined the startup last year, well respected for establishing and implementing clear technology roadmaps and defining vision, mission, and principles. She was actually quite surprised when key leaders in her team decided to leave, so some unintended or unexpected attrition. She's a great visionary leader known for the quality of her decisions. So what might be happening here?
So in this particular case, Cathy, Katherine is great at focusing on the quality of decision, but she may be neglecting the speed of decision at times. So a data science executive is expected to have the decisiveness of an executive and the deliberateness of a data scientist. Now, without the decisiveness, you can miss opportunities and invite doubts to your executive leadership capabilities. And without the deliberateness in the rigorous application of data science techniques, you can lose your data science team's respect. So while decisiveness and deliberateness may seem contradictory, but with a few simple techniques and assessments, you can actually successfully navigate this balance if you have the right leaders reporting to you in your organization. And this, so when you have this situation, you can have the most challenging decisions like remain, and when they are escalated to you, you can use this technique. So first, you can look at whether the decisions can lead to significant positive impact. If they can, then you can continue to evaluate. If they can't, then they can be put on backlogs. Now, the positive impact of moving forward with a decision drives the urgency of a situation. So you can also ask, are there many downsides risk for a wrong decision? If the impact of a wrong decision is low, you can be decisive and accept the risk and move forward. But how do you know if the impact of a wrong decision is low? There are actually pieces in chapter 2 in the book that we mention a technique called RICE, where you're identifying and quantifying a project's reach, impact, confidence, and effort with the acronym RICE. And a similar approach can be used here. What you can also do is to assess, would the indecision bottleneck the roadmap? So far, we have discussed the assessments and the limits of the risk when moving forward. What about the opportunity cost of moving forward? So the opportunity cost is much more difficult to assess, and because they include all the things that you're giving up by not moving forward with a decision. Well, with a clear set of a roadmap, and this is articulated in chapter 6 in the book, you can map whether a delay of some existing milestone can undermine the ongoing goals, ongoing process of achieving some corporate goals. So with that, you can quickly assess whether you need to focus immediately on finding ways to reduce or counter or fix some risks and then proceed.
So there's a little bit of art and a little bit of science. So what we're talking about here is more of the science, and then the art is really the practice of it and getting better and better at doing that. So Katherine is a very good visionary leader, known for the quality of her decisions. And our recommendation for her is, in addition to focusing on the quality, she also want to focus on the speed of decisions. These are the 10 mistakes to avoid, and in the interest of time.
So
very quickly,
there's a few points to make, right? So these mistakes, as you can see, are not limited to people managers. They also apply to individual contributors with various levels of influence in your organization. So they can be staff data scientists, principal data scientists, or distinguished data scientists in your organization.
The data professionals in general. And in fact, more than 80% of the recommendations here would apply in general. So
that's right. And also, people can make these mistakes despite their best intention of doing good, right? You see, for each of these areas, there is a good focus. And if you just focus on the good, the focus part, then all those look great. But there are things behind the focus that we need to balance.
So the roadmap for next steps So it's very good that we're talking about this, but this is technical entertainment, if you will, and it's like learning how to swim in a classroom or over Zoom, even better, right? The key is really practice. And in the book we have sections section 4 in each chapter throughout the book, talking about techniques that you can use. So one is CPR. CPR is choose, practice, and review. And choose, practice, review process is discussed in detail with 2-week check-ins, and you can certainly move on to additional skills, but make sure that you follow the simple steps to make progress before you do. And the second one is grow. That's self-coaching with the grow techniques, and we can have a whole talk on that one alone.
Yes.
And we have recorded a series called Ask Dr. Chong, and it's on some of these characters who were recognized: Jennifer, Audra, Stephen, and Katherine. We also have a couple others that we specifically looked at where they're doing well, where their opportunities are, and how we help them. So leading in data science, how to lead in data science, the topics we touched upon is all included in our book. And we, the 4 stage, that's how it aligns is in this eye chart. So don't try to read it all together. It is on the back cover of the book. And there's actually two paths, one for people manager path and one for individual contributor path. So this is an older screenshot. And at a high level, we actually organized the book in 4 main parts or stages. The characters we introduced today are at different stage of their career growth: tech lead, team manager, functional manager, and company executive. And at each stage, there are 2 main parts: the hard skills, and which we call capabilities, and the soft skills, which are soft social cycle skills, which we call virtues. So if you look at the hard skills, it's TEE. That's technology, execution, expert knowledge. And for the soft skills, soft social cycle skills, that's ERA, ethics, rigor, and attitude.
So for today, what we looked at are the mistakes to avoid with rigor. And out of all the concepts that we touched on in the book, we merely touched this thin layer here across 4 levels of leadership. Specifically, under rigor, yes. And specifically, we talked about monitoring for anomalies in data and in deployment. We talked about observing and mitigating anti-patterns in machine learning and data science algorithms, and avoiding project planning and execution anti-patterns, as well as improving the speed and quality of decisions. And just one piece to add, so as you can see, what we discussed here today covers a few topics, but across different levels of considerations. And we also talk about this concept in the book about thinking 2 level up, is that in order to be an effective leader, you need to understand what your boss and what your boss's boss is thinking about. And the purpose is not just to get around your boss to get to your boss's boss, but your primary responsibility as a leader is to help your boss and your first team, which are everybody reporting to your boss, to accomplish your boss's goal. And your boss's goal is dictated by what his boss would like to do, or her boss would like to do. So that by mapping out the amount of rigor that's required in the different levels, you can get a peek into the next level of thinking and the 2 level up thinking that's required, and how you can be effective in being a team player in your organization.
And different companies also have different cultures where you may be required to do ±1 level considerations.
Yes.
So we are at time, and as you can see, we in how to lead in data science, we have a code for today, especially. You can recognize SF Big Analytics part of that in the code. So feel free to use the code at the Manning site with the
publisher site link and the Amazon link.
Yes.
And don't forget to use this 2D barcode to be able to follow us on LinkedIn, and we'll be selecting some winners from a winner to get a free book.
And the time cutoff is 24 hours from now. So tomorrow at 6 p.m. we will have all the new editions and those that direct messaged us in a hat and have name pulled out from there, and will be announced from that.
Great, back to you, Chester.
Yeah, great talk. Thank you so much, and thank you, Cathy, and thank you, Jackie. So I can test it. It's a great book, and I have, after I got the book, and I've actually I have read through the, to quickly go through the major points, and I try to do a lot of reflection in terms of my teams, how do I lead my team, where I'm management, and even happen to be the planning, the end of the year planning for next year, and I referenced the book and for planning. It's a great reference, a great book. So it's so, and we would like to hear from you. If you have any questions, you probably want to post in the chat, so the author can answer some of the questions. I know Dave has one question earlier, and he's talking about when we're talking about the detecting the distribution changes, and you're referring the PSI, and what does that stands for? Yeah, and I think he was referring, he was thinking about the KL divergence,
yes,
and how that's related to that.
So this is a very specific question. Love to have a much deeper conversation offline, but the Wikipedia page explains this quite well. So happy to have this deeper discussion there.
Sure. Any other questions related to the career, different paths, and they have a, discuss different roles.
Well, I have a question for the audience. I mean, which part of this really hit it home for you? So if you put that in the chat, at least we see that some people were paying attention and people were actually getting something useful out of this. If nobody says anything.
Yeah, DS lead.
Yes, lead. Yeah,
that's good.
Yeah, I actually referenced this the tech lead manager. And said, hey, look at this book.
It's a conversation.
Yeah, so just to speak a little bit on that point, what we found is that data science is still a relatively new field with vague descriptions on what people's responsibilities are. And what we found in terms of feedback for us in early review process for the book is that people actually found it useful to describe to their peers what their responsibilities are. So it helped them, help provide them with a language to speak about what they are there to take on in terms of responsibilities, and what are things that fall outside of those responsibilities where they would need partner help with. So being able to clarify where those responsibilities begin and end, and have a clear request for partners to collaborate in projects was one of the benefits we heard for the audience of this book.
So this talk is meant to give you a 10 mistakes, right? So those are, it's really a sliver of what we cover in the book, and there's a lot, as Chester can test with you. There's a lot that you can get out if you take a look at your specific situation. The personas we have in there are meant to be representative. So, but you may be a combination of all of them, and you may have some things that we haven't covered. So we would love to hear from you on what hit it home, and what additional things that you may want us to consider.
Yeah, post your comments, and which part you like, which part do you want to ask more questions, and we have probably a minute or so. So if anybody has any other questions, post it there.
Mm-hmm.
Of course, you can always follow them on the LinkedIn and ask them more questions afterwards. So,
Yes. And if you are in a large company, what we've also heard is people are looking to share with their colleagues New Year resolutions and how to set those up. So hopefully we could be of help in that area as well.
Somebody comment. I think Victor comment. You could make this book into a recurring drama.
What we found with our is if we break up the discussion into more of a conversation, so every couple of minutes, re-emphasize something focused. So by the end of it, some things will stick.
Yes.
If it's a talk straight through.
Well, actually, I think this is a pretty interesting suggestion. So if someone is interested, would happy be collaborating on a recurring drama like Silicon Valley, the show.
Other books have movies made out of them. Why can't we, right? So this is a book version. 512 pages, 2 to the 9th. We were pretty happy when the number finally came in. 2 to the 9th. Can't get better than that.
Yeah.
Well, we want to thank you for giving us the opportunity to share a little bit from the book, and we hope you find this useful. And please do follow us and ask questions. Let's get a conversation going.
Thank you for both for a great book and a lecture and share the knowledge with us. And thank you for the audience to stay late. So I guess we'll see you next time. Thank you very much. Okay, bye-bye.
Thank you.
Thank you. Bye-bye.